Back in the day, machining a large precision part meant moving it from one machine to another, sometimes a dozen times. Each move risked misalignment, and each setup ate up precious hours. Well, folks, those days are long gone, and what you're watching right now is the future that became reality. This is the CTX Gamma 2000 TC, a marvel of German-Japanese engineering from DMG Mori. That 2000 in the name? It refers to the distance between centers, roughly 6.5 feet, meaning this beast can handle parts that would make your grandfather's lathe look like a toy. We're talking components for aerospace, energy sectors, parts so complex they'd take weeks on traditional equipment. Watch how the workpiece rotates smoothly in the chuck. The cutting tool approaches with almost surgical precision, peeling away metal in a continuous ribbon. But here's where it gets really interesting. See that B-axis? It's rotating the tool head itself, allowing the machine to attack the workpiece from practically any angle without ever removing it from the spindle. This is what we call 5-axis simultaneous machining. While the part spins on its main axis, the tool can turn, mill, drill, and even tap threads, all in one setup. Back in the 50s and 60s, this same part would have required multiple machines, multiple operators, and multiple days. Now, it's done in one go, with tolerances measured in microns, that's thousandths of a millimeter. The beauty of the CTX Gamma TC series lies in its ability to combine turning and milling operations seamlessly. Notice how the coolant floods the cutting zone, keeping temperatures stable and washing away chips. This isn't just about speed, it's about eliminating error. Every time you move a part, you risk losing that perfect alignment. Here, the computer remembers every dimension, every angle, down to a precision that would astound craftsmen from just a generation ago. This is modern manufacturing at its finest, where technology serves craftsmanship and tradition meets innovation. Now, this is something you don't see every day. We're looking at the birth of a hot coil spring destined for the deepest, most punishing environment on Earth, the ocean floor, specifically for offshore oil and gas operations. Start with that steel rod, nearly 3 inches in diameter. This isn't your typical spring steel you'd find in a car suspension. This is specialty alloy designed to withstand crushing pressure, corrosive salt water, and temperature swings that would destroy ordinary materials. First step, austenitizing. The steel is heated to over 600 degrees Fahrenheit, transforming its internal structure. At this temperature, the metal becomes pliable enough to coil. Watch as the massive rod feeds into the coiling machine. Even glowing orange hot, it takes tremendous force to bend steel this thick. The coiling happens while the metal is still hot. That's crucial. Try bending cold steel this size, and you'd snap your equipment. But at temperature, it flows like taffy, wrapping around the mandrel to form those perfect spirals. Next comes quenching and tempering, rapid cooling followed by controlled reheating. This gives the spring its memory, that ability to compress under enormous loads and spring back, cycle after cycle, year after year. The finished product stands nearly 5 feet tall and weighs close to 1,000 pounds. Every measurement is verified, every coil inspected. Because down there, a mile beneath the waves, there's no second chances. This spring will endure conditions that would crush most materials, performing its duty in one of the harshest workplaces humans have ever created. If you flew commercially any time from the 1960s through the early 2000s, you flew on aluminum. Entire airliners, wings, fuselage, tail, all metal, riveted together in sections that would make a battleship jealous. But what you're seeing here represents one of the biggest shifts in aviation history. This is Norwegian Air Shuttle's Boeing 787-9 Dreamliner, and she's different from her ancestors in a fundamental way. About 50% of this aircraft, by weight, isn't metal at all. It's carbon fiber composite, the same material that revolutionized race cars and bicycles, now reimagined for the skies. The 787-9 designation marks this as the stretched variant, longer than the original 787-8, capable of carrying more passengers on longer routes. But it's the construction that tells the real story. Where earlier Boeings were assembled from thousands of aluminum pieces, the 787's fuselage sections arrive as complete barrel segments, massive one-piece composites that simply get joined together. Fewer parts, fewer joints, lighter weight, better fuel economy. Now watch the painting process. This isn't a quick spray job. A 787 spends 7 to 10 days in the paint hangar, and for good reason. At cruising altitude, around 35,000 feet, outside temperatures hover at 60 below zero. On the tarmac in Dubai or Phoenix, it might be 120 degrees. The paint system has to flex with the composite skin, protect against UV radiation, resist jet fuel spills, and still look pristine after years of service. They'll use hundreds of gallons of specialized aerospace paint, applied in multiple layers. First comes the primer, bonding to the composite surface. Then the base coats, building up that distinctive Norwegian tail livery, the bright red tail fin that's become their signature. Finally, clear protective coats that seal everything in. Each layer gets cured and inspected. Remember, this isn't just cosmetics. The paint adds weather protection and can even affect aerodynamics. A smooth finish means less drag, which translates to fuel savings over millions of miles. Standing here watching this process, you're witnessing the intersection of materials, science, aerospace engineering, and good old-fashioned attention to detail. It's how we went from the Wright brothers, wood and fabric, to aircraft that can fly 16 hours non-stop while using 20% less fuel than the generation before. You might think tire service hasn't changed much over the decades, and in some shops, you'd be right. But what you're watching here is a far cry from the corner garage of yesteryear. This is Corgi, an Italian company that's been perfecting tire equipment since 1954, and they've turned tire service into a precise science. Let's start with the inspection. Before any repair begins, the tire gets thoroughly examined, not just a visual once-over, but a systematic check for punctures, sidewall damage, irregular wear patterns that might indicate alignment issues. Modern tires are engineered marvels, with multiple plies, steel belts, and compounds designed for specific purposes. You can't just slap a patch on them like you could with the bias ply tires your dad used. Balancing comes next. The wheel spins on a precision machine that detects even tiny imbalances. Small weights get added at specific points, ensuring smooth rotation at highway speeds. Unbalanced tires don't just cause vibration, they accelerate wear on suspension components, bearings, even the steering system. Finally, pressure check and remounting. Modern tire pressure monitoring systems mean getting it exactly right, not just close enough. Each tire is inflated to manufacturer specifications, accounting for load ratings and driving conditions. This isn't just maintenance, it's preserving the safety systems that connect your vehicle to the road. Now here's where computerized precision meets an age-old product, the humble spring. But there's nothing humble about this XD620WCNC spring former. This is 21st century manufacturing, creating components that go into everything from medical devices to aerospace applications. The XD620W is what we call a multi-axis spring former. Think of it as having multiple robotic arms, each working independently but in perfect coordination. Where old-school spring coiling machines could basically only wind wire around a mandrel, this machine can bend, twist, coil, and form complex three-dimensional shapes, all from a single piece of wire. Watch as the wire feeds in from the right. That servo-controlled feed mechanism measures to within 1/100th of a millimeter. The wire enters the working zone where up to 6 or 8 independent tool heads wait. Some rotate to create coils, others bend at precise angles, still others might cut or form loops. The beauty of CNC control is repeatability. Program it once, and it'll make 10,000 identical springs without drift or variation. Back when springs were made on mechanical formers, you needed skilled operators constantly adjusting cams and stops. Every batch might be slightly different. Now, the computer remembers everything. For complex shapes, like extension springs with loops on both ends, or torsion springs with multiple bends, the XD620W can complete the entire part in one continuous operation. Wire goes in one end, finished spring comes out the other, ready for heat treatment or plating. It's modern manufacturing, where precision meets productivity and quality becomes not an accident of skill, but a guaranteed outcome of process.